All right, thank you for joining me. This is part 28 in discussing infinite solution system of equations. And last time we did substitution, now we're going to do system of equation elimination. I'd like to show you what the infinite solution is going to look like. So here we've got original equation number 1, x plus y equals 1, and the original equation number 2, 2x plus 2y equals 2. Now, these are the same equations that we did substitution with. There's a reason you're not seeing double. Okay, there's a reason why I want to show you elimination. This really helps, especially those students who may be struggling understanding the concept, right? This will help. And I'm also planning, I believe, to graph these two equations as well. So you'll see what an infinite solution looks like when you use substitution, right now when you use elimination method, and then also when you use the graphing method, right? So let's just get on into it. Remember, the goal in elimination is you're going to be adding these values between both of those equations, and you're hoping to eliminate either the x's or the y's through that addition process. Sometimes you need to do what? You need to determine if you need to manipulate or rearrange in order to eliminate when you add these like terms. So if you could see here, there's a few things I could do. But the obvious to me is to multiply a negative 2 times x, a negative 2 times 1y, and a negative 2 times 1, right? And that would help me eliminate negative 2 plus a positive 2x is 0. So let me show you what that looks like. All right, so I'm choosing to multiply each term by a negative 2. I'm distributing, right? Distribution property, simply multiplication. I'm going to multiply the negative 2 times the invisible 1x. I'm going to multiply this negative 2 times the invisible 1y. And I'm going to multiply this negative 2 times the constant 1. And I'm showing you this down below. Negative 2 times 1x is right here. Negative 2 times 1x. And I'm going to separate each operation with a plus sign. Negative 2 times a positive 1y. Negative 2 times a positive invisible 1y. I'm going to rewrite my equal sign. And then a negative 2 times a positive 1 I'm showing you here. Let's go ahead and simplify that a little bit further. All right, so you can see here that negative 2 times a positive 1 is a negative 2. It's attached to the x through multiplication, so it's a negative 2x. Plus, plus. Negative 2 times 1 is negative 2, but it's attached to that y through multiplication, so it's a negative 2y. Bring down my equal sign, negative 2 times a positive 1. Well, 2 times 1 is 2. 1 negative, 1 positive makes it a negative 2 value. So now I've manipulated my equation number 1. Now I'm going to write my equation number 2 and add these terms, like terms, together, and let's see what we get. All right, take a look, here we go. All right, so equation number 2 is 2x plus 2y equals 2. So a negative 2 plus a positive 2 is 0. I'm going to rewrite my plus signs. Negative 2 plus a positive 2 is 0. Rewrite my equal sign. Negative 2 plus a positive 2 is 0. So 0, right? 0 plus 0 is just 0 equals 0. Again, infinite solution. If you come up with an answer like this with systems of equations, infinite solution. Hey, join me for part 29. I'm going to show you what the graphing looks like. I might take a couple of part 29 and part 30 because I like to take my time with graphing. It can be kind of confusing, and I want to be crystal clear. All right, I'm going to graph these two equations and show you what the solution looks like when you get an infinite solution. Thank you for joining me. Math is easy. Take it step by step. If I have helped you, please help me to help others. You know what to do. Like, follow, share, subscribe. Thank you for sharing your time.